Okay, functions trigonometry final exam review, problem number 1. We're given this function, this absolute value function. All right, in order to be successful in these problems, you're going to have to remember your parent function, your absolute value, your cube root, your square root, your quadratic, all those good guys. Okay, now what I'm going to do is this is a transformation on my parent function of absolute value of x. Okay, so this 1/5, we have to decide, well, what kind of transformation is that going to be? Stretch, straight, shift left, shift right, up, down. And one of the basic ways to tell is your transformation are either going to affect your x value or you're going to affect your y value. And how do I tell the difference between the two? Well, if your transformation, your coefficient or your other thing is grouped with your x, in parentheses, in a radical, or in this case with the absolute value bars, you know it's going to affect the x value. If it is outside, like if I added like 5 over here, or something like that, or put a coefficient right here, like maybe a -3, you know, these guys and these guys that are not grouped together with the x in parentheses or some sort of operator, those are going to affect the y value. All right, so what am I going to do with this? I know it's going to affect the x value, these coefficients of the x, the transformation. So I'm going to take all my x values of my parent function and divide by 1/5. All right, so here's my parent function for the absolute value. So this transformation is only going to affect these guys. I'm going to divide each one of these numbers by 1/5. Which is the same thing as multiplying by 5. All right, so then my new x values will look like this. And if I was to plot that out, we could see that this then got stretched horizontally. Okay, so the answer then would be false. It was stretched, but by a factor of 5, not by a factor of 1/5. If this coefficient would have been 5 instead of 1/5, then it would have been true. I would have taken all my x values and divided by 5 instead of multiplying by 5. Okay, what we're looking at here, my parent function is the square root function. The 3 and the x are going to be grouped together because they're both underneath the radical. This is the same thing as saying something like 3x plus 6 to the 1/2 power. All right, so these things are grouped together. If I were to have something out here or something here, okay, these would affect the y values. Same argument here. This 3 is going to affect the x values. This 6 is going to affect the x value. All right, what am I going to do? I'm going to divide all of my x values of my parent function by 3. So that's going to give it a horizontal shrink. And this 6 is going to give it a horizontal shift. I'm going to add this 6 to my x values after I divide all my x values by 3. All right, so if this is a positive, it'll shift left. If it's a negative, it will shift right. All right, so false. This is a horizontal, I should say shrink. And a shift to the left 6 units. Okay? All right. Let's look at number 4. Okay, again, a transformation of this time an exponential function. Okay, so what am I looking for? I'm looking for coefficients in front of the x. That's going to affect the x value of my parent. I'm looking for this coefficient out here in front of the base. That's going to affect the y values. Okay, so here, if I have a negative sign here, that's going to be a y-axis reflection. If my negative sign is here, then I'm going to have an x-axis reflection. All right, so this is false, because it's not an x-axis reflection, it's a y-axis reflection because my negative sign exists here in front of my x value, my x variable, and not here. Okay. Vertical line test. Vertical line test, if I pass, it means I have a one-to-one function. Horizontal line test means if I pass, my function has an inverse. So this statement then for number 3 is false. It asks the function passes a horizontal line test, then it has an inverse. Doesn't mean it's a one-to-one function, so we put false for that one. Oh, I got 3 and 4 switched around. You get it. 5. What is the inverse of cosecant? It's 1 over the sine. What's the inverse of, I'm sorry, I should say this the other way around. Cosecant is the inverse of the sine function. Secant is the inverse of the cosine function, and vice versa is true. So the inverse of cosecant is sine. The inverse of secant is cosine. And problem 5 asks, what is the reciprocal of cosecant? Well, the reciprocal of cosecant is sine, not secant. So this is, again, false. All right, this one is a little bit tricky. What are my cofunctions? Sine, cosine, cosecant, secant, tangent, cotangent. So you would say, okay, sine theta, cosine theta, those are cofunctions. Why is it false? Okay, because it says sine theta equal cosine theta, meaning these two angles are equal. That is not correct. To be a cofunction, in order to be equal, I need to have the complement of the angle. So there's 2 parts for a cofunction to be equal, right? I have to be a cofunction and a complementary angle. So we had to answer false on this. Angles aren't the same, they're complementary. All right, let's look at number 7. Okay, number 7 is given us is sine is negative and secant is negative. What quadrant am I in? Well, we have to remember all students, a smart trig class. All of my trig functions are positive here. The sine and cosecant are positive in quadrant 2. Tangent, cotangent are positive in quadrant 3. Cosine and secant are positive in quadrant 4. So every trig function and their inverse. Okay? So if sine is going to be positive in this quadrant, so its inverse. You got to remember this. Some remember it as all students take calculus, a smart trig class, whatever. All right, well, where is sine negative? Well, sine is negative in either quadrant 3 or quadrant 4. Okay? So that boils it down to these 2 quadrants. Where is the secant negative? All right, the secant is negative in quadrant, do I have this right? Yeah. Secant is negative in quadrant 2 and in quadrant 3. All right, so what's the common quadrant? The common quadrant here would be quadrant 3. And the S in the question said, does it lie in quadrant 2? That's false. It had to be in quadrant 3. All right. Number 8, law of sines. If you remember the law of sines, the sine operator or the sine term is in the denominator, not the numerator. So again, this is false. Okay, one last one, and then we'll finish up some more in part 2. Domains. All right, there's lots of rules for domains. Here's a couple of them right here. X cannot be a value, so there is a 0 in the denominator. X cannot be a value so that I will have a negative under a radical. All right, here I've got kind of a double jeopardy. All right, I have to look, I've got a radical in the denominator, so I'm going to handle that. Well, first of all, let me look at the no zeros in the denominator. So that means that x minus 1, this term in here, my domain has to be such that that is always greater than 0, because I do not want a 0 in the denominator. So that means x has to be greater than a positive 1 to keep a 0 out of the denominator. Okay, so that's one criteria for my domain. What's the other criteria? No negatives under an even radical, square root, fourth root, sixth roots, things like that. Do not have negatives under the radicals, otherwise you have imaginary numbers. All right, but I can take the square root of 0, that's okay. All right, so according to this radical, I need to keep it positive, so that means x has to be greater than or equal to 1. So which do I choose for this domain? Well, I choose the one, the criteria that both will meet, or kind of the more stringent criteria. All right, so if x is greater than 1, I fit this criteria and this criteria. So that is the one I choose. So my domain is x has to be greater than 1, or I can write it in interval notation and be equally correct. Okay, we'll continue with problem number 10 on video 2.